Welcome to the date farm monitoring, date collection and date classification system by Stuart, Medjo and Bitu for our PDE 4423, PDE 4426 and PDE 4427 combined group project. I'm going to be walking you through the various aspects of the system. As you can see at the moment, you're looking at the farm monitoring robot. What this robot does is every hour this robot will go and collect data from each of the 3 farms, and it will publish that data via a ROS topic, or several ROS topics, one for each sensor in fact, and that data will be recorded in a database. This data is used by the date ripeness algorithm in order to assess the ripeness, as the name would suggest, of various dates. And based on a research paper that we've included in our project, 3 of the main factors that affect the ripeness of dates are the number of days that the date has been growing for, the mean number of sunshine hours that that date farm has received, and the average temperature that the date has been grown at. So the database is queried for the ideal conditions, which we've made up for now, for each of the different 8 date varieties, and the data that we've gathered based on hourly monitoring for each of the date farms, for each of the date varieties, is also gathered. Then a calculation is done and a figure is produced based on the percentage difference between the ideal and the actual data that has been collected. And if that figure is positive, then that will tell you the date is probably overripe. And if the figure is negative, it will tell you the date is underripe. And we've set a pick threshold for those dates arbitrarily for now at a 15% difference. The date collection robot will then go and visit the farm with the best figure. So for example, if one farm produced 20 or 0.2, then that would be considered overripe, and the date collection robot would not go and visit that farm. Whereas if one produced minus 0.05, that would be slightly underripe, and if that was the closest to 0, then that's where the date collection robot would go. As you can see in the video now, there is a date classification system, so the webcam will take a photograph of the date as we pass through a convolutional neural network which we've trained with transfer learning, and I'll talk about that in a moment. And that is the very date that is passed into the system in order to make a decision about which farm we are going to go and visit. We initially used transfer learning with GoogleNet in order to classify the dates, but that was simply a copy of what we did in class with Dr. Maha. So we decided to invent our own system, which was similar but different, and use ResNet 18 in order to do this. So taking ResNet 18 and making sure the image input layer was aligned with the correct image size, which in our case was 224 by 224 by 3, which it was. We then needed to remove the last fully connected layer, as that was trained for the 1000 categories within ResNet 18 at the moment, and we needed to completely retrain that layer for the 8 date categories that we were looking at as part of this project. And finally, I had to replace the date classification layer, or the final output classification layer as it is, so that that could be completely retrained as well. Now the trick with this, when setting up the convolutional neural net, was supplying the right training parameters. I had to play with the different epochs, trying 30, which ended up with overfitting, and it seemed that 8 would give us the correct fit, having tried many different epochs. Also, looking at the batch sizes, we have only 15 images of each date available to us. So what we did was we tried doing validation sets, but found actually that we were better off using the full 14 images for training and just a single image for testing. And when we ended up using real dates for our live system from different packs of the same variety, we actually ended up with surprisingly good results. the most important factor when training our transfer learning CNN seemed to in fact be the learn rate. Setting that learn rate too high somewhat obliterated the data that was on the system on the neural net already, and setting that too low meant that it didn't start to classify the dates correctly. So there was some trial and error with that, and we found that 0.01 in fact gave us a good learning rate, and we got the data fitted correctly within 8 epochs. Now that the date has been classified, the date category is published on a ROS topic, and it's picked up by the farm monitoring robot. And the farm monitoring robot goes off to the relevant farm, and this is after it's been through the date rightness algorithm to find out which farm it should be visiting. And it goes to the correct farm and it checks, verifies the rightness and availability of those dates in fact. It then returns back to base, and the date collection robot will follow a predetermined route to the farm and will in fact collect the dates. So it's going to drive all the way to the farm. And again, this is all done via ROS. So what happens is the farm monitoring robot publishes to ROS the success in assessing the availability and rightness of the dates, and then the date collection robot is told which farm it needs to go to, arrives at the farm and waits to have the dates loaded, as you can see, a manual process in our system at the moment, onto the robot, and then the date collection robot drives back to the base in order to deliver the ripe dates to the customer who is waiting for their juicy, tasty and ripe dates. We're going to have a little bit of a look now at what's happening on the system in terms of ROS and topics. We've got a distributed system, obviously with 4 devices. So we've got the date classification system in MATLAB with a camera. We've got the 2 robots we've talked about, and then you're now seeing the master system on the screen. And the master system obviously is coordinating all of the activities and looking at the ROS messages, passing them on to the database, telling the farm monitoring robot to go off and conduct its actions, telling the date collection robot to go off and conduct its actions. And you can see on the screen now all of those monitoring messages confirming that each of those actions have been completed successfully at the appropriate points. Just a few words about some of the references in our project write-up. Obviously, a lot of the MATLAB references were used. There was plenty of information published by MATLAB about how to do transfer learning, and that was followed in order to train up ResNet and arrange the classification system that you see here. Then there was the research paper that used to verify the most important conditions that would affect the growth and rightness of a date. And finally, we'd actually like to thank all of our teachers and professors on this course, without whom this would not have been possible. We hope you found this project interesting and informative. Thank you very much. Majo, Stuart and Bitu.